I'm here to do an educational experiment. It is about lunar craters and how they are formed and what are the factors that cause these craters to be formed. So as you can see here, these circular features on the surface of the moon, they are called craters, and you can see that there are quite a few bit of these circular patterns on the moon. And then you can also see there is a ejecta patterns that happen due to the impact, and those are called your rays. So we're going to recreate that here. So for this experiment, what we are testing is I'm going to have the surface of the moon as a form of this container. So I'm using a glass container, but just make sure that you're very careful when you're using the glass equipment, because if it is too crowded on your experiment bench, this can slip and fall. So instead of this, the precautionary way is to replace it with a plastic container, or if you have at home, if you're doing with any steel trays, even that is fine, but you just need at least 1.5 inch thickness. So I'm using flour here, and I'm also using some sprinkles to create that as if like the moon would have had its minerals. So I'm adding a little bit of sprinkles, and then I'm covering with some chocolate cocoa powder or a brownie mix powder you can use, or you can just use sand, but cover up these sprinkles, so you're creating this surface. So for this experiment, I'm actually testing a hypothesis, that is, if I increase the drop height of these marbles, so basically these are the rocks that would have impacted the surface of the moon, causing these craters formation. So what we are doing is, instead of these rocks, which could be asteroids, meteorites traveling at the speed of sound, I'm just using marble. So the size and the density of this is not changing, but in this is just in theoretical experimental. We are testing this, but the sizes of the rock and the density would have varied. Okay, make sure that when you're having marbles around you, don't keep them in a container, safe and sound. Don't let it play around, and don't let the marbles roll over on the floor, because accidentally people can trip and fall on. It can cause head injuries as well. Now we also need a meter stick ruler, because we are going to change the drop heights from to 25 centimeters, 50 centimeters, and 75 centimeters, and we're going to repeat the experiment. So you do need a meter stick ruler. Then you also need a small ruler, because when we drop the marble from different heights, we are going to see if there is any difference in the diameter of the crater. So we're going to measure the diameter, probably in millimeters. We'll see how big it's going to be, and then here it's going to be in centimeters. Then next we are going to use the same setting to do a second experiment, because not all the rocks would have been dropped perpendicularly. So we're going to test it at a different angles and see how this is going to be creating different lengths and widths for the craters. Alright, let's begin the experiment. So I'm going to put this away. So right now you just need, I'm going to hold, you can also have, for support, you can actually use a different support. I do have something like this with a wooden plank that we made for another experiment. So I'm just going to use this as a support to hold my meter stick. But if you are doing this with students, and there are 2 or 3 of them, then we can they can help each other. So 25. So I'm going to do 25. I'm going to do a drop from 25, 50, and 75. So here's my marble. So as I said, please make sure that you close the lid back so you can avoid any trip hazards. Alright, so I'm doing my first drop at 25 centimeters. right there. So this is somewhere here. And alright, we can clearly see that some of the minerals have just ejected out, creating the rays, and the rock would have sunk in. So here is a very clear crater formation. So you can actually measure now with your centimeter ruler the diameter of this crater that I just created with my marble at 25 centimeters is roughly 1.9 centimeters. So we'll repeat another experiment. So we will drop another marble from 50 centimeters. So we're going to see how this will create an impact. So this is roughly 50 centimeters. As I can see that there's more ejector rays that I can see here. Let's measure the diameter. So the diameter for this one has gone up to 2.7 centimeters. We'll repeat this one more time with another marble at 75 centimeters. Okay, 50 and then 91. Right there, that's my 75 centimeters. And I want to see if this creates a bigger impact. Right, so there we go. It was much deeper. I can hear the glass sound here. I don't know if you have paid attention to that. Now, the diameter for this one is, if you consider everything, the splashes, it's like roughly 3 centimeters. So you're going to record this into the worksheet that I'm providing. So you're going to, and then do the average. Continuing the second part of our hypothesis, the additional factors that could have impacted the crater formation could be the angle at which the rocks would have hit the surface of the moon. So what we are going to do for this part of the experiment is you do need a ramp. Okay, so this can be like a wooden plank. Right now I'm just using some of my Hot Wheels ramp. And then you also need a protractor. Protractor is a tool that helps you to measure the angle. Okay, and then that's it. So we are going to continue our rocks as marbles, and we have flat, and make sure that you flatten the surface to recreate more craters. So flatten this out. Alright, so I'm going to do in the worksheet, it gives you different angle measures. So you're going to set up your ramp based on that angle measure it from here to 10 degrees, 30 degrees, 50 degrees and 70 degrees. So our hypothesis is if we increase the angle of impact, will the dimensions of the crater, meaning the length and the width, or is it going to stay circular, or will there be any changes in the dimensions? So that's what we are testing. Alright, and then you're going to record your measurements in the worksheet. Alright, so starting, I'm actually going to do 10 degrees right now. So what I'm going to do is I'm going to see if the rock or your marble, what sort of crater it would create. So if you have more than one person in your team, is quite helpful. Okay, right there. Alright, so it kind of extended itself and then came back and settled. So the kind of crater that I see here is a little bit different than circular. So right now, it doesn't have a deep impact, but the surface has been disturbed and some of the minerals on the surface, a little bit deeper from the surface, has come out. So I got a measurement. The length is like 4 centimeters and the width is like roughly 1 centimeter. So now I'm going to show with one more. So let's say I'm increasing my angle all the way to like roughly 50 degrees or so. So then let's see what happens to my, so let's flatten this out so I can take the second measurement. Alright, so like this you can see that the length is again increasing. So if a rock would have hit the surface at a different angle, the depth and the width and how the rock would have traveled a little bit further on the surface, that's what we are going to check. And so these are all the factors that would have impacted on how these craters are formed on the surface of the moon. This animation shows a model of formation of a complex crater. Initially, there is a bowl-shaped cavity which is excavated, but as the crust rebounds, a central peak forms within minutes. The walls of the crater collapses and forms terraces under the influence of gravity, leaving behind a shallower and wider crater than a simple crater. Now, this animation again does not reflect the accurate timescales, but it can give us some information about how these complex craters are formed. All these animations are actually taken from NASA for our own understanding. I'm actually going to run an animation which is not a true representative or reflects the accurate timescales, but this is called Schrodinger Basin. It is located in the southern part of, it's called located in the lunar south pole, and it is considered to be one of the largest craters that are located on the surface of the moon, roughly the diameter being 320 kilometers. Now, most craters are usually 50 kilometers in diameter, or it varies, and the smallest ones are like roughly 15 kilometers, but this one is 320 kilometers in diameter, and this is named after one of the famous Austrian Irish physicists who won Nobel Prize for his contributions in quantum theory, and it is pronounced as Schrodinger Basin. What we are actually seeing here is Schrodinger Basin is a large impact feature on the far side of the moon near the lunar south pole, and the visualization of this basin shows the cycle of sunlight and the shadow highlighting the inner peak ring and outer rim. So just wait for it. There you go. So we can clearly see the inner peak ring and the outer rim. Alright guys, thank you for watching this video.